Hello everyone, welcome to Edu-Malanga. We do mathematics tutorial videos for Matric in South Africa. Today we are doing example 3 of the sum of arithmetic series. This is the third lesson under the first unit of the year, which is patterns, sequences, and series. If you're joining us for the first time and are unable to understand this example, there is a previous video where we introduced the sum of arithmetic series. So if you go back and watch that, you'll be able to follow what happens in this example. Let's get into example 3. Example 3, the question goes like this. Term number 3 of an arithmetic sequence. So we're merging our knowledge of arithmetic sequences and series. Arithmetic sequence is equal to 7 and series to 10. So which means when you sum up the first 10 terms of this arithmetic sequence is equal to 195. The question then is determine the first 4 terms of the sequence. So let's get started with our solution. To solve this question, we'll have to use our knowledge of arithmetic sequences as well as the knowledge we've learned on the sum of arithmetic series. Let's start by looking at the arithmetic sequences. And to do that, we'll start by reminding ourselves of the general term of an arithmetic sequence. The general term of an arithmetic sequence looks like this. Tn is equal to a, which is the first or the starting term of your sequence, plus open brackets n minus 1 close times d. D is the common difference and n is your term number. So this is the general term of an arithmetic sequence. If we come back to our question, let's see what we've been given. We're given that term number 3 of an arithmetic sequence is equal to 7. So we're given that T3, which is basically what Tn is equal to 7. And from that, we can also see that n is equal to 3. We're going to take what we're given and substitute it into the general term of the equation to start our solution. So let's get going. Tn becomes 7 because we know what it is equal to, we don't know what a is yet, plus we know what n is because it was given to us as 3. 3 minus 1, and we also don't know what d is. So we're going to have the equation look like this. Let's simplify the equation. We have 7 is equal to a plus 3 minus 1 is equal to 2. So that's equal to 2 times d. Let's make a the subject of the equation by moving the 2d from this side of the equation to the other side. That means the sign is going to have to change. So we're going to have that a is equal to 7 minus 2d. We're going to call this equation that we've come up with equation number 1. Let's come back now to our question. We see that we've been given series to 10 is equal to 195. We'll start by writing down what we're given because there were 2 equations that we used when dealing with the sum of arithmetic series. Let's write. We've got series to 10 is equal to 195. And from this we can read that n is equal to 10. Out of the 2 equations that we derived for solving problems to do with the sum of arithmetic series, the one equation required us to know the last term. And because we don't know the last term, we haven't been given in this question, we're not going to use that equation. We're going to choose the other equation. And the other equation looks like this. Sn is equal to n over 2, open big brackets, 2a plus, and you open smaller brackets, n minus 1 times d, and then you can close all your brackets. So we're going to substitute in again everything that we have into this equation. to come up with another equation. Let's get started. Sn is going to then equal to 195, should equal to, our n is equal to 10, so I'm going to have 10 over 2, open brackets, 2a, we still don't know what a is, plus, we know what n is though, it's equal to 10, so we have 10 minus 1 times d. We'll then simplify this equation. 195 will stay the same. 195 should equal to 10 divided by 2 is equal to 5. And we'll open brackets. The 2a we can't simplify any further. Plus 10 minus 1, that's equal to 9. So plus 9 times d. We can simplify this equation by dividing by 5 on both sides of the equation. Divided by 5. The 5s are going to cancel out on this side, and on this side you'll have 195 divided by 5. That's equal to 39, which is equal to 2a plus 9d, because the multiplication bracket is gone as the 5s have cancelled out. Let's call this equation that we've come up with equation number 2. If we look at equation 1 and equation 2, we can see that there's two unknowns, which is a and d in both equations. And because we have two equations and two unknowns, we can use simultaneous equations to solve for the two unknowns. Let's rewrite equation 1 on this page. Equation 1 is a is equal to 7 minus 2d. Equation 1. So we're going to substitute in 7 minus 2d wherever we see a in this equation in order to solve for d. Let's get started. 39 is equal to 2, and we're not going to have a, we're going to put in 7 minus 2d, so we're going to put brackets, 7 minus 2d for our substitution, plus 9d. This equation now only has one unknown, which is d. So let's simplify everything and we'll then be able to solve for d. Equation will be 39 is equal to 2 times 7 is equal to 14 minus 2 times 2, that's equal to 4d, plus 9d. Let's group like terms by moving the 14 to the other side of the equation. We'll then have to change the sign. We get 39 minus 14 is equal to minus 4d plus 9d. We'll now simplify the two sides of the equation. 39 minus 14 is equal to 25. It's equal to minus 4d plus 9d, that's equal to 5d. Because we're solving for d, we'll divide by 5 on both sides of the equation. These 5s are going to cancel out, and in the end we're going to have d is equal to 25 divided by 5, that's equal to 5. We've now solved for d. Let's come back to our equations. We can substitute in what d is into equation 1 and we'll be able to solve for a. So the equation will then be a is equal to 7 minus 2, and our d we solved for as 5, so 2 times 5. A is then equal to 7 minus 10. 7 minus 10 is equal to negative 3, so a is equal to negative 3. We've now solved for a and d of the arithmetic sequence we were asked about in the question. Let's write down its general term then. The general term for that sequence would be Tn is equal to, our a is negative 3 plus n minus 1 times our d, which we solve for as 5. If we come back to the question, we were asked to determine the first 4 terms of the sequence. What are the terms that we have so far? So we know what a is, we solved for it. A is our first term. So we have term 1, which is negative 3. We don't know what term 2 is though. We don't have that. And if we look at the question, we can see that we've been given that term 3 is equal to 7. And we were supposed to find term 4 as well. So out of a total of 4 terms, we just need to solve for the 2, term 2, and term number 4. And to do this, we're going to use the general term that we've derived over here. Let's get started solving for the 2 terms. Term number 2 is going to equal to, our n will become 2 in the general term, so it'll be equal to negative 3 plus, open bracket, 2 minus 1 times 5. That simplifies to negative 3 plus 2 minus 1 is simply equal to 1. So negative 3 plus 5, which is equal to the number 2. So term number 2 is equal to 2. We can come and write it in there. And all we have to find now is term number 4. We'll do the same thing we did for term number 2 and substitute in n is equal to 4. We'll have that T4, term number 4, is equal to negative 3 plus, open brackets, 4 minus 1 times 5. We'll simplify what's in the brackets. We're going to have negative 3 plus 4 minus 1, that's equal to 3. 3 times 5. And if we go further, we'll have negative 3 plus, let's write the negative 3, plus 3 times 5, that's equal to 15. So negative 3 plus 15, we have that term number 4 then is equal to 12. And we can come and write it in our sequence over here, 12. And we've just solved the question that asked us to find the first 4 terms of the sequence, where term number 3 is equal to 7, and the sum of the first 10 terms is equal to 195. I hope you were able to follow and understand what we're doing in the video. I hope you understand why we used simultaneous equations, and that when you find a question like this in your exams, you'll be able to solve it. Thank you for joining us in this video. Join us again in the next video where we will do the last example on the sum of arithmetic series.